Now let's deal with one of the interesting circuits called amplifiers, basically about RC coupled amplifiers. Any circuit that increases the signal strength is an amplifier. Amplifier accepts low power input signal and gives high power output signal without changing the basic characteristics of the input signal. Amplifiers are classified based on coupling elements, operating regions, frequency response, and applications. The circuit of an RC coupled amplifier is basically a voltage divider bias circuit. Capacitors C2 and C3 are coupling capacitors at input and output respectively to block DC and just pass AC signals. CE is a bypass capacitor at the emitter. It is basically needed to stabilize the AC operating point and to remove AC degeneration. RE is used as a negative feedback resistor which stabilizes the circuit. Without CE, RE will nullify the effect of small AC input. This is called AC degeneration. The design is based on the collector current. Input and output impedances play an important role in the accurate design. The Thevenin equivalent of R3, R4 and C2 at the input side act as a high-pass filter and is responsible for the first half of the input, that is the frequency response. Similar action of a low-pass filter takes place at the output side, which is responsible for the second half of the frequency response. The RC coupled amplifier network is broadband in nature. It gives wideband frequency response without peak at any frequency and hence is used to cover a wide frequency range amplification band. Some of the applications are in audio small signal amplifier, video amplifier, mixers in RF amplifier. Now let's get to the working of the circuit. When the input is provided to the base emitter junction, the biasing levels change due to the variation in the voltage at the base emitter junction. This results in change of collector current across the load which is passed on to the output via C3. Now let's get to the simulation part. To vary the input, just click on the function generator. We get a control panel. It gives us options of a sine wave, triangular wave and a rectangular wave. The frequency and amplitude of the wave can also be varied here. Set the output level of the signal generator to around 10 mV peak. Select the sinusoidal output. To check the output, click on the oscilloscope. This is similar to the CRT used in the lab. Here we have two channels. Channel A, which is connected to the input, and channel B is connected to the output. Three options for coupling are provided for both the channels. They are ground coupling, AC coupling and DC coupling. In CRO, we have various options to change the scale, position, time base, etc. To view the output, run the simulation. As we see, the input is amplified and the output is in volts. Thank you.